Hey guys, welcome to the notes for quadratic applications and regression. We're in Unit 7. We're actually in the last lesson of Unit 7, yay! And then our essential question is, how can quadratics be used to model and solve real-world situations? So we're going to be going through a variety of problems here. We're first going to go over one that we're talking about a modeling equation where we're using the equation given and then using our graphing calculator to help us. In the second problem, we're actually going to be using quadratic regression, which is super similar to linear regression. We learned it in Unit 4. And then we're going to use our graphing calculator to help us find the dimensions of a rectangle, and then also find another problem where we're finding the dimensions of the rectangle, except we're just finding the width. And then the last thing we're going to learn is intercept form, which is creating an equation using the x-intercepts any given point on that parabola. So we're going to have a variety of 5 different problems here. So I just want to make you aware of that. They're all a little bit different from each other, but they all model the homework pretty well. So starting with number 1, Timmy has a Tshirt cannon that models the path h of t equals negative 16t squared plus 72t, where t is the time in seconds, is h is the height in yards. So basically he's shooting a T-shirt out of a cannon. So of course, if we're thinking about it, I'm going to draw like a poorly drawn cannon here. Here's my cannon. And he's shooting a T-shirt in the air, so it's dropping down and it's going to fall down eventually on the ground, right? So he's shooting a T-shirt up and it's going to fall down. So they're telling us that that equation there is going to give us that modeled path. Now, the problem is, if I want to graph this in a graphing calculator, I can't use t's. I have to use x's. So let's go ahead and translate this into language that we know. So instead of x's here, what did they use? They use t's. Now remember, x is always considered time, so the fact that they say t is time, it already tells us that x is the same thing as t. So we're going to go ahead and rewrite that equation as negative 16x squared plus 72x. So anywhere I see a t, I'm just going to replace it with an x. Again, why am I doing that? Because when I type it in my calculator, I can't even use t's. I want to use x's. Now remember, that means that this t is also just h of x, right? Equals, my bad. Forgot that at the beginning. Now remember, what's the same thing as h of x? The same thing as h of x is actually technically y. So we can actually even get rid of this and make it even easier for ourselves and just write a y there. So that's really the equation that we have, and we're translating it into a way that we understand it. So instead of t being time, x is now time. Instead of h being the height, y is now the height. So I'm going to go ahead and just use variables that we're used to seeing. So remember, instead of instead of x's, they used t's, and instead of y, they used h of t, which is the same thing as like h of x. All right. So the question is, how high is a T-shirt at 2 seconds? So again, that's where I'm going to go in and use my equation that I just wrote, and I'm actually going to keep that as h of x. Okay, so I'm going to use the equation I just wrote. H of x equals negative 16x squared plus 72x. But again, that's the same thing as y equals negative 16x squared plus 72x. Okay, so we're going to use our calculator to help us find this at 2 seconds. Now, there's 2 ways you can actually solve this. You can actually solve this using algebra, and then you can actually solve this using your table. So I'm going to first show you using just plain old algebra where you're plugging in stuff. So we know that seconds is time, and they say 2 seconds. Well, seconds in this problem is time, which is t, but for us it's going to be x, so x equals 2. Time is 2. So we can actually plug in a 2 here into our equation. So we have y equals negative 16, and in parentheses I have 2 squared plus 72 times 2. Okay, so that's going to give me y equals, and I can actually type the entire thing into the calculator. So negative 16, 2 squared, and I'll go ahead and show you my calculator in a little bit so you can see what I typed in exactly as I typed it in. Oops. Oh my gosh, it just cleared everything. Oh, that's what happens, I guess. Alright, so I'll go ahead and show you my calculator screen. Oops, sorry, I was dragging the little stand over. So that's what I'm typing in my calculator, negative 16, 2 squared plus 72 times 2, and I get 80. So what does that mean? I got 80 as my y. Well, instead of using h of t here, I used y. So that means I got 80 here. What does that mean? That means that at 2 seconds, how high is a T-shirt? It's 80 yards. So they used yards here, so we want to say that it's 80 yards. So it's 80 yards high at 2 seconds. Now, what's an even better way? You can actually just use your calculator and not have to use any math at all. So what I'm going to do is I'm going to type in this equation into my y equals screen to graph it. So I'm going to go to my calculator. Oh, I think there's a helicopter flying there. So I'm going to go over to my y equals, okay, and then I'm going to type in negative 16. Remember, you want to make sure you're typing in a negative and not a minus sign. x squared, remember we're replacing all those t's with x's, plus 72x. Okay, so that's the equation that we're given, y equals negative 16x squared plus 72x. And then I'm going to go ahead and go look at my table, so it's going to be second graph. And so here's my table. Now the question was, how high is the t-shirt at 2 seconds? Remember, seconds is time, so we're looking for 2 in the time column. So time is x, so we're looking for 2, and at 2 seconds, the t-shirt is 80 yards high, because y is our yards, it's our height now. So at 2 seconds, it's 80 yards high. Or you could say at 4 seconds, it's 32 yards high, but they wanted to find 2 seconds, so that's how we got 80. Okay, moving on to the second part. We are asked to find what is the maximum height of the t-shirt. So here's where we're going to use our calculator to help us. So I'm going to go ahead and write the steps for you, and then we will actually do it in the calculator. So finding the maximum height is actually very similar to finding an x-intercept using the graph. So the first step is you're going to go ahead and graph it. So you're going to actually hit the graph button so you can see your graph. The next thing you're going to do is you're going to do second trace. So don't do anything yet. Just go ahead and write down the steps. Do second trace. And then the third step is an important step because that's the step where you're actually going to type in what you want to find. So I'll go ahead and skip that for now. And then it's going to ask you for your left bound, your right bound, and then it's going to ask you to guess. Remember, when you're asked to guess, just hit enter. Okay, so you don't want to actually type in a number. So you're just going to press enter there. Okay, so we're going to find the maximum height of this t-shirt. So I'm going to go ahead and go to my calculator. So here's my calculator, here's my table. I'm actually going to go ahead and hit graph here. And I'll show you what that looks like. So you'll see that the parabola is going to, shoots up, and then it goes back down. So it goes up and then back down. So this is a parabola that opens down because it is a Tshirt cannon, right? You throw it up and then it goes back down. So you kind of want to think about the x-axis like being the ground. So this is like the ground. You're starting at 0, 0, 0 times 0 height, and then you're shooting the thing up and then you're shooting down. This part of the graph is irrelevant to us because your height cannot be negative, and you can also not have negative time. So that's why the bottom half of this graph is voided. So we're pretending like we're starting at 0, 0. Okay, so we're asking us to find the maximum height. So the first step is you're going to hit graph, which was what we did, and you do second trace. Okay, and it wants you to find the maximum height. So here you're going to type the choice 4 for maximum because you're looking for the maximum height. So you're going to press 4. Okay, and then it's going to ask you for the left bound and then the right bound. So when you're asked to find the maximum, you're basically trying to find the maximum of the entire thing. So I like to trap my entire parabola inside of my dotted lines. So for the left bound, I'm going to pick the whole number to the left of my quadratic. So the entire quadratic, the number to the left of it. So I'm going to choose -1. So -1 is my left bound, and hit enter. And you'll see that there's a dotted line at -1. Then for right bound, right, it's asking me to find the right bound of this entire quadratic. Remember, I'm trying to find where it's at the very top because I can't see it. You can't see it up here, but the maximum is up here somewhere. So I want to find the right bound, so I'm going to trap my entire thing. So I'm going to pick the whole number to the right of the entire quadratic. So +1, +2, +3, +5 is what I'm going to choose. So +5 and enter. You'll notice the entire thing is trapped inside. Here we're calculating the maximum. We're not looking for an x-intercept here, so x-intercepts you do a little bit differently, and you'll see that in a little bit. For a maximum or a minimum, you want to trap the entire thing because it just makes things easier. For a guess, you're just going to hit enter. And it gives you a maximum. So it's listing 2.25. We'll go ahead and round that to 2 decimals. 2.25, and then your y value is 81. So I'm going to go ahead and write down that point. And so, again, we're drawing a little picture about what's happening here, right? So your quadratic is going up, and then it goes back down, right? And so we're trying to figure out what this point up here is, where that maximum point is. We're trying to find the maximum. Oops. We're trying to find this point up here, which is the maximum. But we don't know what that is, so that's why we're picking some bounds to help us. So we picked a bound at -1. And then we picked a bound at like -5, so I trapped the entire thing in there. And I'm trying to find that maximum point. Okay, so remember that choice 4, so go ahead and fill in your notes. After we did second choice, we selected choice 4, which was maximum. Because you're asked to find the maximum here. And you're like, how do I know that? Well, the question says, what is the maximum height? So I know that I want to find the maximum here. Oops. So I'm trying to find the maximum. Okay, so I get the point in my calculator, and it gives me 2.5 or 2.45, comma 80. Is it 80? 81. Sorry, 81. Okay, but it's asking for the height. So the question is, what part of this is my answer? Because they're asking for the height of the t-shirt. They give you an ordered pair. They give you an x and a y. Well, what does your x represent in this problem? Your x is your time in seconds. So this is actually seconds. So what does that mean your y values are? Your y values are your height. So this is your height here. Okay, they're asking for the maximum height. They don't care about the seconds. So what is the maximum height of this t-shirt? The maximum height is 81 yards. And again, if you're wondering where I got yards from, it says that the height is in yards for this problem. All right, moving on to part C. When will the t-shirt reach its maximum height? So they're saying, when will it reach its maximum height? Well, we know it reaches the height at 81 yards. So when does it reach that? We actually answered that in the previous problem when we got that point. When it reaches it is at 2.45 seconds. So at 2.45 seconds, it reaches its maximum height at 81 yards. So it actually reaches it at 2.45 seconds. So we got a 2-for-1 special with part B. It gives us 2 of our answers there. All right. I'll go ahead and underline that. So, oops. Okay, moving on. When will a t-shirt hit the ground? So I'm going to go ahead and draw that little picture that we had. So this is kind of a mimic of what you see in your calculator, right? So you see a quadratic that goes like this, and then it goes like this, right? So I want to know when it will reach the ground. Well, remember, this is the point 0, 0. That's 0 height, 0 distance. So this is your seconds. I'm going to use a different color than red, actually. Let's use pink. So down here is your seconds, and down here is your yards. Okay, so again, at 0, 0, that's when it starts. That's when you launch the t-shirt. So at 0 height, 0 seconds, you're launching the t-shirt. It's at the ground, and then it goes up. And then it's going to hit down at the ground again. So basically, it's asking, when will it reach the ground? So we're asking, when will it fall on the ground? So we're basically asked to find this point over here. They want you to find this point. When will it hit the ground here? Because your x-axis is like your ground. So basically, it's asking you to find the x-intercept because that's the x-intercept point. It's on your x-axis. So we're going to go ahead and find the x-intercept here. Now remember to do that, the steps for that will be, go ahead and write that here. You can do second trace. Just a reminder, some of you probably already know this, second trace. But for this option, you're going to hit the number 2 option, which is 0. You're asked to find the x-intercept. Remember, 0 is the same thing as an x-intercept. And then you're going to do your left bound, and then your right bound. And then it's going to ask you for a guess. Oops. And then remember, you just hit enter for that. You don't actually have to guess. Okay, so we're trying to find that point over there, which is your x-intercept. So we're going to go ahead and go back to our calculator. Okay, so again, I'm going to do second trace, but instead, so the previous problem I found the maximum, but here I want to find the x-intercept. I'm trying to figure out when this t-shirt's going to hit the ground. So that's going to be your 0, so I'm going to press 2. Again, remember your t-shirt's being shot up and then landing, and so it's going to land here somewhere. We just got to figure out what that point is. So here I'm trying to find the 0. I'm trying to calculate for the x-intercept. So here I want to trap the x-intercept in. So for the left bound, I want the number to the left of the x-intercept. So it's going to be positive 1, 2, 3, 4, positive 4. And then to the right of the x-intercept would be positive 5. So I'm trapping the x-intercept. So this is different from the maximum. The maximum, I want to trap the entire thing. For x-intercepts, I just want to zone in on that x-intercept. And so again, your dotted line should always be on the opposite sides of that one x-intercept, because you're trying to just tell your calculator, hey, I want you to look in this area. So those dotted lines are telling your calculator where to look. For guess, you hit enter, and I get 4.5, 0. So I'm going to go ahead and write down that point, so I know that's important. So I get 4.5, 0. Okay, so let's analyze what this point means. Remember, what are your x values in this problem? Your x values are your seconds. That's your time. Your y value is the yards, or the height. So here it's saying that at 4.5 seconds, your height is 0, which means, that makes sense, right? Because after 4.5 seconds, your height is 0 because your t-shirt's on the ground. So it says, when will the t-shirt be on the ground? So the question is, what part of this is our answer? The part of this that is your answer is the 4.5 part, because you're saying that at 4.5 seconds, that's when your t-shirt's going to land on the ground again. Oops, that's such a wiggly line. All right, the last question is, what is a reasonable domain and range? So we're going to go ahead and find domain first, and then find range second. So we'll do domain first. Now, question is, first, before you do domain and range ever, you ask yourself, is this continuous or discrete? Now, it's been probably a really long time since you've heard that. Remember, discrete, you want to list out your numbers. So discrete means you can only have whole numbers. Continuous means we're going to use inequality signs. Remember, you got to think about your problem. We're talking about time here, and we're talking about height here. So if you can have half of something, it's continuous. So for example, you can have half of a gallon. That's continuous. But you can't buy half of a chocolate bar. That's discrete. And here we're also talking about time, and time is continuous, so this problem is continuous, which means for my domain and range, I'm going to use inequality signs. So for this problem, my domain values, so we used x, right? So the problem used t, so we'll go ahead and write with t later, but I'm going to use x for now. So our time here is x. And so we're going to use inequality signs. So I'm going to have inequality signs on both sides, and it's always less than signs, always less than. Okay, and you're going to always want it with the least. So remember, what is domain in this problem? Well, domain is your x values, right? Domain is your x. And what is x in this problem? Your x in this problem is seconds, okay? So your x is seconds in this problem. I'm going to go ahead and write that over here. So you're thinking about seconds. So what's the least amount of seconds he can shoot the t-shirt into the air? Well, the least amount of seconds would be 0 seconds. He doesn't have to shoot the t-shirt in the air. And it can be equal to 0 seconds. And then it says, what is the maximum amount of time that t-shirt is in the air for how many seconds? Well, the t-shirt's going to land back on the ground at 4.5 seconds. So after 4.5 seconds, it's no longer in the air. So 4.5 seconds is the maximum time that you're going to have. And it can be equal to that. Okay, let's review that. X is seconds and X is domain, right? Domain is X value. So you're looking at all your possible X values. It's not all real numbers here because it is a real problem. You're not asked to like do a random graph here. So anytime it's a word problem, it's not going to be all real numbers. Or it's probably not going to be all real numbers. It can be sometimes. All right, so for our domain here, again, 0 because it's the least amount of seconds your t-shirt can be in the air. And then after 4.5 seconds, it's now on the ground. So that's the maximum time that it's in the air, from 0 seconds to 4.5 seconds. Because remember, we calculated that. When will the t-shirt be on the ground? All right, so let's find our range next. Now, range is your y value. So that's going to be your y, and you're always going to have less than signs because we're with inequalities right now. Okay, range in this problem is your y values. Well, what is y in this problem? Your y in this problem is the height. So we'll go ahead and make that height here, or also known as your yards. Okay, your height in yards. So the range is what's the least amount of yards or the least height that your t-shirt can be. Well, the least amount of height could be 0 because the t-shirt could be on the ground, right? If the t-shirt's on the ground, your height is definitely 0. And it can be equal to 0 because your t-shirt can be on the floor. And then you're asked for the maximum height. What is the maximum height of your t-shirt? Well, we calculated that. What was the maximum height of this entire t-shirt? The maximum it can go was 81 yards. So 81 yards was the highest it can go, and it can be equal to that. Now, what happens after 81 yards? The t-shirt starts falling back down. So 81 is the highest it reaches, and then it goes back down onto the ground. And I forgot to box my answer here, so it's going to bother me. So let me do that real quick. All right, so that's how you would do one of those problems. You're going to have a couple of those on homework. All right, here, I love these because they're so easy. You're going to use quadratic regression, similar to linear regression. So remember, regression is just the process of our calculator trying to help us create an equation. Back in Unit 4, I gave you scatter plots. Like I showed you guys some scatter plots, and I say, hey, draw a line of draw a trend line. And so you guys would draw a trend line to try to go through your points, right? So our calculator is going to do that for us. They're going to create this line for us, and then they're going to give us the equation, right? So because we're in quadratic unit, our model, so you see if our data here, it looks linear, right? Like this looks like a line. But we're not in a linear unit. We're in the quadratic unit. So what's going to happen is they're going to give us a table. And that table is going to have a bunch of points on it. And if I were to plot them, they're probably going to look all willy-nilly and look something like this because it's a quadratic. So we're going to ask our calculator, hey, can you create an equation for me that kind of goes through these points? So it's going to create something that looks like this. Or it's possible that you get a graph and then your points look like this, right? And so your calculator will give you a quadratic that kind of looks like this. So it's going to model the data as best as possible for you. So that's basically what you're asking your calculator to do here with quadratic regression. Okay, so anytime you're given a table, it's best bet to use quadratic regression or linear regression, just depends. So because they're telling us to use quadratic regression, we want to make sure we're using quadratic regression. We're not linear anymore, it's quadratic, okay? So pay attention to the wording. So we're going to go ahead and go through these steps again and kind of going through all of that. So here's the steps on the side. You're going to do stat edit, and then you're going to do something else. So I'm going to go ahead and show you my calculator. Turn it on actually because it's off. Okay, and remember to quit out of any application. You see how blue is quit here. You can hit second mode and it will quit. Oops, I didn't do that. Second mode. Okay, so I'm back to my screen. Hit clear. All right, so first thing we're gonna do is hit the stat button. Stat button is located right there. And you're gonna hit edit because you're gonna create your list. You're gonna hit enter. And you'll see you'll have L1 and L2. Remember, L1 is always your X, L2 is always your Y. So that's the third step. After stat and edit, you're gonna do L1 and L2. Okay. Remember, L1 is always your X, L2 is always your Y. So the question is, which one is X here, time or height? Time is always X, so that means Y must be our height. So it means L1 is going to be your time column or your time row, and then L2 is going to be your height here. So we're going to type those numbers into our table exactly the way it is. Remember, the important things to remember when you're typing in your numbers is that you type it in exactly how you see it on the paper. 4, 5, and I'm actually going to type 5 twice just to show you I made a mistake, right? So let's say I make a mistake on accident. Is there something on my screen? I can like see it on the camera. Oh gosh, I made that worse. Give me 1 second. Let's see if I can, is that better? Oh yes, that's a lot better, okay. So let's say I typed 5 twice on accident when there's actually a 6 there. What you do is you just go back to that number that you messed up and you just type in a 6. So type 6 and then hit enter and it'll fix. So you have 0, 1, 2, 3, 4, 5, 6, because that's our X column. And then we're moving on to L2, I have 9, 7, 3, 4, 8, 10, and 19. All right, 2 things to remember. You type in exactly what you see on paper because if you type in one wrong number, your calculator is going to give you the wrong equation. The second thing is you make sure that you have the same number of things in both columns. If you have 5 things in the first column, you have to have 5 things in the second column. If they don't have the same amount of things, you're going to get an error. So you always want to be super careful with that. All right, after you type in L1 and L2, what's our next step? You're going to hit stat and then calc. So you're going to hit stat again. Stat's here. And then you're going to go over to the calculate screen because now you're actually going to calculate the equation. You're going to move over to calc, and you're doing quadratic regression here. So back in unit 4, we typed in 4 for linear regression. Well, here we want to do quadratic regression, which is going to be option 5. 7 is quartic regression, so that's not what we're doing here. We're doing quadratic, so it's going to be option 5. So I'm actually going to go to my notes and fill that part in. So fifth step is number 5. We're going to do quadratic regression. Okay, so I'm going to press number 5, okay, and then it's going to say X is your L1, Y is your L2, that's correct, and you're going to go down and press calculate. All right, and then it's going to give you an equation in standard form, y equals ax squared plus bx plus c. So we know standard form, and then it gives you your a, your b, and your c. So go ahead and write those down in my notes just so I don't have to hover over my calculator anymore. Okay, so our calculator gave us standard form, so let's do that first. It gave us y equals ax squared plus bx plus c. It gave us standard form, so we know that. That's good. And then it gave us a, b, and c values. So I'm going to go ahead and write down what I see on my calculator. I'm just going to write as many as maybe 4. 10833. My b here is negative 5.0357, and then my c is 9.595. 2. And then I have those as my A, B, and C values, so that's what my calculator is giving me. Now, when we're actually writing the equation, I only want to keep about 2 decimal places. So I'm going to round to the hundredths here. And I'm going to plug those in. You're going to plug in A, B, C where you see them. So we have y equals, our A here is going to be 1.08. Oops, keep messing with the 1.08 x squared. Plus your b value here is going to be, oh, so that's actually negative. B value here is negative 5.04. So remember, we're rounding to the hundredths place, so you want to make sure that you're rounding to 2 decimal places correctly. So this 3 here would actually round up to 4 because 5 pushes it up to 4. Remember, if it's 5 or bigger, you're going to round up. And that's going to be x. And then your c value here is positive 9.59. Oh, so it actually rounds to 9.60, actually. 9.60. So we want to round to 2 decimal places, but that's going to push that up to 0, so it's going to end up being 9.60. So that is our regression equation. So that's the first part of this. We've got the equation. So our calculator did all of that for us. We didn't have to do anything. All we needed to know how to do was to type it into our calculator. The next thing it asks us is, what is the height at 10 seconds? So we're actually going to use the equation that we got and then calculate the height at 10 seconds. So we have, go ahead and copy that down, y equals 1.08x squared minus 5.04x plus 9.60. Okay, and then at 10 seconds. So remember, we're asked to plug in 10, but the question is, do I plug it in for x or for y? Well, remember that you're asked to plug it in for 10 seconds. And if I look at my problem, I know that seconds on my table was my x value. So that means they're telling me to plug in 10 for x, so x equals 10. So anywhere I see an x, I'm going to plug in a 10. So y equals 1.08. And remember, anytime you plug in, you're always going to use parentheses because you don't want to make a mistake. So 10 squared minus 5.04 times 10. Oops, that bothers me. I need to fix that. Boop. Okay. And then my 5 is looking kind of janky over here. And then plus 9.60. So you can actually type this all into your calculator and calculate that. And I'll go ahead and highlight this so we can see that that's what we're doing. So anywhere you see an x, you're going to type in a 10 or plug in a 10. Okay. So I'll go ahead and type that into my calculator as is. Okay. So we're going to type in 1.08 parentheses 10 squared minus 5. Is it 04? Or am I going crazy? Is it 04? It is 04. 0410 and then plus 9.60. And I get 67.2. Well, what did I just calculate for, right? I got y equals 67.2. So what does that mean? Okay, it says what is the height at 10 seconds? So that means I solved for the height at 10 seconds. So that means that for this problem, the height is going to be 67.2, and what's the unit we used here? Feet. So our answer is 67.2 feet, because that's the unit that we're in. There we go. All right, moving on. Oh, I better not use blue because I used blue earlier, so purple, why not? Okay. All right, number 3. So this one is a little bit tricky because it's not super obvious, so I would definitely suggest that follow along as best as you can. It is going to be in your homework, so I do suggest that. And I believe there's a problem in your review that is just like this one, or similar to this one. So 3 and 4 are going to be really similar to each other. Now, it's going to seem really weird at first, but once you get the hang of it, I think you guys are going to be able to, you might like it, I don't know. All right, so we're asked to find the dimensions here, so I'm going to go ahead and read the problem. The length of a rectangle is 5 less than twice the width. The area is 322 square feet. Find the dimension. So we're actually given the length and the width, kind of the, we're given some information. We're not given a ton of information. We're given that area is being calculated, and we know the length of the rectangle. So let's go ahead and plot down what we know here. So area of a rectangle. I know area of a rectangle. That is length times width. So that's A equals length times your width here, L times W. Now, the order doesn't matter. You could do W times L too. It doesn't really matter again. Okay, also, it tells us another thing. It says that the area is 322. So I actually know the area. I'm going to go ahead and plug in what I know. So I know 322 equals LW. Following along so far? Okay, we know that bit of information. And then I actually kind of skipped over that first sentence. The length of the rectangle is 5 less than twice the width. So I'm going to go ahead and choose a shortcut to make this equation, and it actually helps if you go backwards. So it says the length of the rectangle is 5 less than twice the width. All right, so we're going to go backwards and actually show you how easy this is. All right, go backwards. What's the first thing in that sentence? Or the first thing in the end of the sentence is we're going backwards, width. So go ahead and write width. Okay. Okay. The next thing it says twice the width. So twice the width, how would we write twice the width? That'd be 2W, right? 2W. So we're going backwards. Again, we're going backwards in the sentence. And then it says 5 less than. How do I make 5 less than? Well, that would be 5, subtract 5. So we're going to subtract 5 from that. And then I have is. What does is mean in math? Is means equals. So I have equals. So again, we're just going backwards. Equals the length. So length is going to go last right there. So it literally went backwards in my sentence, and that's actually the shortcut to write this equation here. All right. So now we have 2 equations. So we're going to use a little bit of knowledge from substitution from Unit 5 to help us with this problem. Again, this one's going to be pretty weird, so please just kind of follow along. It's going to be very similar in your homework as well, and I think in the review. Okay. So right now we have two equations. We have 322 equals LW and 2W minus 5 equals L. So we're going to use substitution here because I can only plug in one equation into my calculator. So I know that L equals 2W minus 5. L is already by itself. If L is already by itself, then I can get that stuff and plug it in for a variable. The question is, do I plug in 2W minus 5 for L or for W? I plug it in for L because it says equals L. So I'm going to plug this in for the L, oops, right here. Oh my gosh. I'm going to plug it in for that L. So I'm going to go ahead and write down what I have. So I have 322 equals, now anytime you plug something in, you always use parentheses. So we have 2W minus 5, right? 2W minus 5. And then times W on the end. Okay. Okay. Now, I want to use my graphing calculator to help me, but in order to graph something, one side has to be equal to 0. So I need to move everything to one side and it has to be equal to 0, which means 322's got to go to the other side. So I'm going to move it to the other side by subtracting it. So 322 minus 322 is going to be 0 equals, we have 2W minus 5W minus 322. Okay, so again, how do we get here? Okay, we know the area of a rectangle and we knew the area. The problem gave us the area. And then we knew the other equation because they told us at the very front end, and I just translated that backwards. Then I used substitution. It said L equals 2W minus 5, so I plugged that in for L. But I want to use my graphing calculator to help me, so I need to plug in, I need to get it equal to 0. So I have it equal to 0 now. Here's the problem, like we learned in the first problem. You can't type in different variables in your y equals screen. What's the only letter that you can type in your y equals screen? The only letter you can type in is x. So we're going to replace all of these w's with x's. So we have 0 equals 2x minus 5 times x. So anywhere you see a w, we're going to replace it. So we're basically getting rid of all of our w's. So again, we're taking our w's and we're converting them or changing them to, remember, W stands for width, so we're just changing our W's and making them into X's. That's what was happening here. Okay? Okay, now we can actually graph this. So, okay, so we're going to go ahead and type that in. Again, this problem is super weird. I know. It doesn't make a lot of sense. And again, all these problems are super different, so that doesn't help either, right? Y equals screen, we're going to graph this. So we're not going to graph it, we're going to look at the table. So remember, we don't really care about graphs unless we really need the graph. So parentheses, 2x minus 5, parentheses x minus 322. So that's what we have now. Again, we replace our w's with x's, and then we're going to hit second graph. Okay, we have a bunch of negative numbers, right? Okay, that's obviously not what we want. So question is, what the heck are we looking for, right? Okay, so we're solving for x-intercept here. So typically, what variable is over here? What variable is typically over here? Typically, the variable that's over here is your y value, right? This is typically y. So we want y to be 0. So that's what we're looking for. So in our table, in our calculator, we have an x column and we have a y column, right? X column, y, and we have a bunch of numbers in both of those columns. But I want y to be equal to 0. That's what I'm looking for. I'm looking for 0 in the y column. So I'm trying to find 0 in the y column, so I got to figure out that. So that's what I'm going to do. I'm going to scroll until I find it. Now, right now, y is a bunch of negative numbers. So I notice that these negative numbers are slowly increasing and getting closer to 0, right? It's at negative 32, and then it's slowly. So I think we need to go in that direction. So we're going to go down, and we're going to look for 0. All right, so I found 0. 0 in the y column, because remember, we want y to be equal to 0. We're looking for the x-intercept, basically. So what is our x value when y is 0? It's 14. Okay. So in our table, in our calculator, we've got that x was equal to 14 and y is 0, because we're looking for y to be 0 here. And again, we'll have practice with the next problem, because this is super weird. So we got x equals 14. But what is x in this problem, right? We changed it because there wasn't an x originally. What did we make? What is x actually? X is technically your w, so that means that your width is 14 feet. Okay, so they told us, okay, well, they gave us w, and we're like, okay, well, I can't type in a w, so I made it x. So now we have w equals 14 feet. But the question was, find the dimensions. What's a dimension, right? Dimensions just means you want to find all of the measurements of the entire rectangle. So that means we want to find width and the length. So right now we have the width, The width is 14 feet. But we want to find the length as well. So what does that mean? We're going to use our equation that we started. So we're going to use substitution. If I know that width is 14 feet, I can just plug in 14 for W. So using the equation from earlier, 5W minus 5 equals L. I'm going to plug in 14, because W equals 14. I'm going to plug that in for W. So we have 2 times 14 minus 5 equals L. All right, well, 2 times 14 gives me 28 minus 5 equals L. And then 28 minus 5 gives me 23 equals L. So what does L mean? Remember, L is your length. So your length is 23. So what's our answer here, right? Well, our answer is the 2 dimensions. So our answer here is that the width is 14 feet. And then we got the length as well, and the length was 23 feet. So there wasn't a ton of math we had to do. It was only really math towards the end and a little bit at the front. So we found the dimensions, the width and the length, because they wanted to find both. So that entire thing is our answer there. All right, moving on to the next problem. And there's only 2 problems left, so I'm sorry. I'm trying to explain this as best as I can. The width of a rectangle is 1 less than twice the length. The area is 45 square centimeters. Find the width. So similar problem, right? So let's go ahead and translate what we know. So again, they gave us the area this time, and we're talking about a rectangle again. And just remember, you go backwards to translate for that first sentence. Go backwards to translate. Oops. Backwards, so I'm going to go the opposite direction. All right, so again, we know that the area is length times width. Okay, but they also told us that the area is 45 square centimeters. So we already know that the area is 45, so let's go ahead and plug in what we know. Area is 45, so 45 equals LW. Okay. And let's go ahead and translate that first sentence, right? So first thing, remember, go backwards in the sentence. So the first thing in the last thing in the sentence is length. So we're going to start off with length this time. And it says twice the length. So twice the length means I'm going to multiply length by 2. Now you're not always going to have to multiply to the length or the width. It just depends on the problem. So it says twice the length. And then it says 1 less than. So 1 less than, subtract, so minus 1. If it said more than, you would add. And then it says is the next word that we see, and that means equals. And then it says the width of the rectangle. And so width is the next thing that we see, so width is going to be on this side. So again, translating is just go backwards. It makes it a lot easier. All right. So now I have 2 equations. Now what do we do next? Just same thing as the last one. You're going to substitute in what you know, because you can only type in 1 equation when we're looking at our table. So you're going to take L minus 1. You're going to plug that in for what variable? Do you plug it in for L or for W? You're going to plug it in for W. It says W equals that. So W is going to get plugged in this time, okay? So we have 45 equals L, and then in parentheses, 2L minus 1. Remember, you're using substitution, so that W gets replaced with 2L minus 1. You're subbing that out. All right, now I want to graph this in my calculator, but I can't graph unless it's equal to 0, so I'm going to have to subtract 45 from both sides. Okay, so now I have 0 on the left, and I have L, and then times 2L minus 1, in parentheses, minus 45. Okay, so I'm just putting it towards the back end there. And then the next thing is, I can't type in different variables other than x. So in this problem, what am I replacing with x's then? I'm going to replace the l's with x's. So here I'm taking l's, and I'm making them into, or I'm going to put them and make them into x's in my calculator. So we have the exact same equation, but we have 0 equals, instead of l's, we're going to have x's. So x, parentheses, 2x minus 1. Minus 45. Okay, so now I'm going to graph. Now remember, you're going to type this into your y equals screen, because you're going to use your graphing calculator to help you. You're going to go to y equals. I'm going to hit clear on that. So here we have x in the front, and then 2x minus 1 minus 45. Okay, so this is what we have here. Again, make sure, remember you can't type in X's or L's, you type in X's and you hit second graph. Again, what are we looking for here, right? So what are we looking for? Again, we know that your y value, usually y is on that side, right? Because like y equals, but this 0 is in place of that y. So we're looking for 0 in the y column. So in your table, you have x and a y. I'm looking for 0 in the y column. Okay, so I'm looking for it, because remember, your length and width can only be positive. So it looks like to get towards 0, it's actually getting smaller as we go up. So I want to get towards 0, because I'm looking for y in the 0 column. Oh, and I found it. So 5, 0. So at 0 for y, it's going to be x equals 5. So x is 5 here. Okay, so we got 5 for there. So that means x equals 5. Okay, x equals 5 here. But what is x in this problem? Is it your length or is it your width? Well, remember, we took all of our x's and they were l's. So that means that our l's are that. So L equals 5. 5, what's the unit for this? Square centimeters. So this is going to be centimeters. Okay? So remember, we took l's and made them x's. In the previous problem, we took our w's and made them x's. So it just depends. Now, what did they want to find in this problem? Let's go ahead and look at that. They said find the width. Right now, we have length. So they don't even care about the length. They want us to find the width. So if the problem asks for length, we'd be done, because length is 5 centimeters. But they want us to find the width. So that's not what we need. So we're going to use the equation that we started with at the beginning. 2L minus 1 equals W. 2L minus 1 equals W. Okay, and we're going to use substitution here. Well, I know that L equals 5. If L equals 5, I can plug in 5 for which letter? For L. So I'm going to plug that in there. So I have 2 times 5 minus 1 equals W. Okay, 2 times 5 is 10. And then 10 minus 1 is 9. 9 equals W. So again, what is the problem asking for? The problem asks to find the width. So they don't even care about the length. They don't even care about it at all. In the last problem, they wanted to find the dimensions. They wanted both. Here, they only want the width. So that means our answer here is going to be just the width. And we got W equals 9, which means our answer is that the width is 9 centimeters. And again, I know that it's in centimeters because they told me the area is in square centimeters. So that's how I know that that is what the unit is for that. Whoops, trying to move this over here. There we go. All right, last problem in our last problem, unit 7. Is that exciting? So exciting. Okay, so first thing we're going to find intercept, or we're going to talk about intercept form. So we haven't really talked about intercept form. We've talked about standard form, we talked about vertex form, and this is the kind of one that not a ton of people talk about because it's kind of like, so intercept form is also called factored form because it kind of looks like factoring. It looks like you have 2 sets of factors. So I'm going to go ahead and write it. So it is something new. So we have not gone over this before. Y equals A. Remember, A is in all forms, right? A is in vertex form. A is in standard form. Remember, vertex form is A times x minus h squared plus k. And standard form is ax squared plus bx plus c. So vertex or intercept form is A parentheses x minus p and then x minus q. So it kind of looks like factors. If you think about, like, you have 2 sets of parentheses, so it's kind of like factors, which was why it's called factored form as well. The key here is that your p and your q are x-intercepts. P and q are x-intercepts. Okay, P and Q are x-intercepts here. Okay, so what are x-intercepts, right? So let's talk about that for a second. X-intercept. So an x-intercept, remember, how is that written? How do we write it as a point? It's always number, comma, 0. Okay, number, comma, 0. So if P and Q are your x-intercepts, then that means one of your x-intercepts is P, comma, 0, and the other x-intercept is going to be Q, comma, 0. But here's the thing that's super important. You see how they're in parentheses, and you see the little minus sign? Those minus signs make them opposite signs. So you want to remember opposite signs here. Okay, see how P and Q are positive here, but they're negative inside the form, so it's actually opposite signs. So anytime it's in parentheses in with a negative, it's going to make them opposite. And the reason why they're negative is because those minus signs make them negative. I mean, make them opposite, not negative. The negative signs make them opposite signs. All right, so now we're going to write an equation in intercept form, which is also known as factored form. Again, so I'm going to go ahead. Intercept form is also known as factored form. Okay, those are the same thing. So again, I'm going to write down intercept form at the top here. So it's going to be y equals a, x minus p, x minus q. All right. So this is our intercept form here. So we're going to look for our x-intercepts here. So they're giving us a graph. So first thing is, if they're asking you to find intercept form, they're probably giving you the x-intercepts already. And so here, if I look at my graph and I look at my x-axis, which is actually right here, and here's my y-axis, and they plotted some points for us as well. So the x-axis here is going to give us our x-intercepts. So we have two x-intercepts here. We have one at -2, and we have one at +3. So let's go ahead and identify our x-intercepts. That's the first thing you should do. Identify the x-intercepts. One's at -2, 0, and the other one's at 3, 0. So let's plug in what we know, okay? Remember, intercept form is this right here. That's intercept form. So first step, identify your x-intercepts. Second step, plug in what you know into intercept form. We know that one of the x-intercepts is -2 and the other one is +3. So I'm going to go ahead and plug those in where I know. Remember, your x-intercepts are your p and your q. So let's plug in what we know here. Y equals a, parentheses x. So one of my x-intercepts, and again, it doesn't matter the order. Actually, you can actually put the 3 first or the 2 first. It doesn't really matter, but I'm going to do the 2 first. Now remember, one of the x-intercepts is -2, but when I plug it in, it's going to be opposite. It's going to be +2 here. Okay? And then the second part, I have x, and then your q is the other one, so it's going to be -3 because it's opposite signs, and then I close the parentheses. So here's what I know so far. But remember, the only two variables you should ever have in your final equation should be x and y. So that means we need to figure out what a is, and they didn't give us a at all, so we need to find a. Now I know a is going to be negative because this parabola opens down, so a has to be negative here, so we know that it has to be negative. So here's what happens. Notice how the quadratic gives you a point. The problem gave us a point here. It gave us the point -1, 2. It gave us our x and our y here. They gave us a random point on the quadratic. So we're going to use that point to help us. So again, we're going to use the point -1, 2. Go ahead and circle that or something so that like people in the annotated notes understand what I'm talking about. Okay. -1, 2. So I'm going to plug those in for x and y because I'm trying to solve for a here. I don't know what a is. I got to solve for it. It's kind of like when we're writing vertex form and you don't know the a, you have to solve for it. It's the same thing here. You got to solve for a. So for my y value, I'm going to plug in a 2. Again, I'm using the point they're giving me so that I can find my a value. So y here is going to be 2 equals, again, I don't know what a is. I'm solving for it. And then for x, I'm going to plug in -1 and then +2. I don't know why I'm writing these so close together. I'm going to drag that out a little bit. And then I have another x. So again, x is still going to be -1. So anywhere you see an x, you're going to plug in -1. Anywhere you see a y, you're going to plug in a 2 because that's the point that they gave us. Now, they could have given us any of these 3 points as well. So it's just a point that they decide to give you. And then -1, and then close your parentheses here. All right, now we're going to simplify. And notice how inside our parentheses, we have regular numbers that we can just combine together. So that's what I'm going to do. So I'm going to have 2 is going to be on the outside here because 2 is the same, and then a, and then I'm going to go ahead and combine my parentheses. So inside my parentheses, I have -1 and +2. So -1 plus 2 makes +1. And then in my other set of parentheses, I have -1 and -3. -1 minus 3 is going to be -4. And that's still in parentheses. So just combining the stuff inside the parentheses. Okay. Oh, wait, did I do that wrong? Oh, I did that right. Okay. So then I have, we're going to simplify down. So I have 2 equals a. Well, what's 1 times -4? Well, 1 times -4 is going to be -4. Okay, 1 times -4. But that looks kind of weird the way it's written, so I'm going to reword it. We don't typically write a times -4. We do -4a. I'm going to rewrite it as 2 equals -4a. And I'm just solving for a. So how do I get a by itself? I'm going to divide both sides by -4. And I get a equals 2 divided by -4 is going to give you -1/2. Okay, remember you're typing this in the right order. It's 2 divided by 4, so it's 1/2. Not 4 divided by 2 and to give you 2. So make sure you do that in the correct order. Move this up, actually. Move all of this up. Okay. So I get a equals -1/2. Now, this is not my answer. It's just my a value. So at the very beginning, we knew our x-intercepts. Oh my gosh, hello? Okay, we knew our x-intercepts. So this was what we had at the very beginning, but this wasn't complete because we didn't have our a value. So I'm going to erase that a value knowing that my new a value is negative 1/2. So that's my a value, and this is my final answer. Okay, so again, we did all of that work just to find their a value. So that's how you would go about writing an equation in factored form, or also